Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your mineralogy teacher, Jen, and it's time for Throwback Thursday. This is Sir George Gabriel Stokes, 1st Baronet. And yes, I'm saying it the right way, Britain. It's not a baronet, it's a French word. Baronet. Please. Anyway. He was born in Skryne, Ireland on August 13th, 1819 to Reverend Gabriel Stokes and his wife, Elizabeth Houghton, or Houghton? I'm not sure. Sometimes Brits pronounce GHs and sometimes they don't, and I never know which way to go. You guys are very confusing with your English, and people think American English is bad. I really don't have anything against the Brits. I really don't. I have fun with your TV shows, but I am going to make fun of the way you guys speak a lot because I took French, and it kills me to see the way you guys pronounce the French words, and I'm American, so, I'm going to make fun of your English because you guys can make fun of mine. I don't know. It's just the way things are, right? I really have nothing against you guys. My family, long time ago, came from England, so I have no feet to stand on for that. But anyway, moving on. George was the youngest son, with 3 of his brothers also joining the clergy following his father. George had another calling, though, and he became a renowned mathematician and physicist. So why am I a geologist talking about a physicist? For a few reasons, actually. His main work was in fluid dynamics, which has a huge impact on the flow of river channels, which is part of hydrology and geomorphology. However, it was his work in optics that caught my attention as I did research on scientists for this month. In 1852, he wrote a paper about the change of wavelength of light, in which he described the phenomenon we now call fluorescence. He said that substances like fluorspar, or fluoride, and uranium glass had the power to convert invisible ultraviolet radiation into radiation of longer wavelengths that are visible to our eyes. Today, this is known as the Stokes shift, named in his honor. Now, the Stokes shift is the difference between positions of maximum absorption and emission spectra. Basically, when a system absorbs a photon, it gains energy and enters an excited state. The system then relaxes when it emits that photon, and if the energy of that emitted photon is lower than that of the absorbed one, the Stokes shift occurs. Neat, huh? Well, thanks for coming to today's lesson, and make sure you tune in tomorrow to learn more about Sid the Sloth. Fossilize later.